Hi, I'm gonna present my paper for the Requirements and AI workshop at the RE20 conference. This is actually supposed to take place in Zurich, so please look at my background. Unfortunately, however, due to the given circumstances, I'll present it now as a video. That means I have to share now my screen. And I have to go to the presenter mode. And that is how it goes. The paper is actually entitled Towards an Extended Requirements Problem Formulation for Superintelligence Safety. The RE problem thing is a RE thing. And superintelligence safety topic is actually an AI topic. So it really comes together for this workshop. It will probably be good if I talk a little bit of what superintelligence safety means, and I will do that. First of all, my name is Hermann Kaindl, and this is work together with Jonas Ferdigg, who is actually a student of mine. The outline of the presentation is, as a brief introduction, I will talk about the challenge of superintelligence safety. I will talk a little bit about RE for superintelligence. So far, by the way, I happen to talk about these topics already at the rescue-related workshop recently. The core of this particular presentation is towards a new theory of the RE problem. There's a very particular point here to make. After that, I will briefly conclude and sketch future work. Yeah, what is superintelligence safety? Maybe you have heard about the famous book by Nick Bostrom with this title. He happens to be a philosophy professor at Oxford. And yeah, and this kind of thing has actually penetrated already through the newspapers and so on. So maybe you have heard a little bit about it. If not, I will explain anyway. And the key point here is actually that the superhuman AI could be a threat to humanity. Is that true? I don't know. Elon Musk just today, at the time of my recording, said this would happen in a few years already, while other people said this could be decades, or others might say that it will never happen. Somehow, I think you will have to believe in this for the talk now, because otherwise it may not seem very reasonable. I mean, today I do not think there's this threat, but it may come. You never know. Never say never again. Yeah, there is actually a film that you may have heard about, I hope maybe even seen, by Stanley Kubrick, 2001: A Space Odyssey. And it actually is a lot about these things. Yeah, and the Terminator movies, and you name it. And then there is, in Greek mythology, King Midas, or Midas as the US people would say. I don't know how the old Greek people would have pronounced it. And yes, and there's a very nice movie, Bedazzled, and all these things go for this topic. It's really interesting, however, that for a long time, people didn't realize that it's a requirements problem. So I happened to attend ICHKA 2 years ago in Stockholm, and actually a few famous people there talked about this, but never ever said anything about a requirements problem. And I'm both an AI person and an RE person, and so it's actually up to me to make sure this comes together finally. I mean, for the Bedazzled theme, for instance, there's a devil as a woman, and there's a young man, and there's always this old story with name your wish, and young man says wishes, and then the specifications, of course, not very precise, and the devil fools the guy. So that's how it goes. And in the rescue workshop, I actually showed already that this is solvable. Yeah, you can never precisely say what you want, even when you use a formal language, and then it will be incomplete potentially, and you will have no grounding and things like that. Yeah, so it's really about yet another RE problem that I coined, namely figuring out the wishes and the needs with regard to superintelligence. And finally, as a point of this particular presentation, there is a goal-oriented requirements engineering that includes goals, but how about goals created by an AI system itself? And this is the open question here, actually. So for the challenge of superintelligence safety, yeah, it includes minimizing the essential risk to humanity posed by superintelligence agents. So wow, yeah, a threat to humanity. Yeah, again, believe in it, please, for a moment. And how could you control the superintelligence and avoid doomsday scenarios? And then there is really an interesting point here. I mean, this thing that you cannot precisely say what you want would even be a problem for a benevolent system, because even if it want to help you, I mean, you are not precise, it may badly go wrong. I will make a famous example here. Malevolent means, yeah, it actually wants to do you bad like the devil, and then, yeah, it would not even help if you say precisely what you want, because then the malevolent could always not do what you want. So what is about motivations goals? You have goals, I have goals, humanity has goals, I hope so. How about an AI system? And this is actually what it was done here for us. Because if we give a goal and it would pursue the goal to the best of its abilities without being constrained, then this example is to make as many paper clips as possible. And this was supposed in this community to come along as an objective function, something like that. Yeah, and of course you might think, yeah, there can be trade-offs and you can do anything, but in the idealistic example, kind of, this superintelligence would simply go and convert everything it can grasp in this world and whatever universe and make paper clips out of it. It sounds a bit contrived, I admit, but the key idea should be clear. Yeah, if you give a goal and this superintelligence takes it, and even benevolent would do nonsense. So I think we should, if we take it seriously, think about requirements engineering for superintelligence. And why? Because, yeah, it's probably an AI-based software-intensive system. That's actually what my professor position is all about. And software-intensive systems, and yeah, and this would be an AI-based one. And it, yeah, I guess we could build something like that along these lines. If it will become super intelligent, we shall see. But I guess it will be along these lines. And another point is, yeah, from the RE community, we'd say, yeah, include requirements engineering. Yeah, for any software system, include RE. For a software intensive system, include RE. For an AI-based software intensive system, yes, please include RE, although this isn't happening all the time, because so many AI systems, I understand, are simply built in order to come up with something new and very intelligent and can solve something others cannot solve, or more quickly, whatever, but it's not typically based on requirements. So yeah, and when it's calling for super intelligence, then I think we really should include the RE, because then we could possibly formulate safety requirements and maybe put them as constraints on the super intelligence somehow. A tricky thing here is, however, that safety, normally, I know it from funded projects together with industry, from railway and automotive, would have something like functional safety for a while now. And this means you have a function and it may have a failure, very important concept. And when it fails, it may come to a hazard, and this can become an accident. And finally, there is a safety risk with a certain probability that some harm is coming. In safety, this is actually that people might be injured or even die, and this should be avoided. However, in the situation we're facing here, there are possible hazards even if none of its function has a failure. Because, yeah, it's not it might, I mean, is it idealistic now? For a moment, it might work perfectly, but it might still put harm on us. And this is really a new dimension kind of for viewing safety, new kind of safety requirements we will need. And there will have to be major stakeholders involved. And this is yet not my major thing here. Just in terms of what Bostrom would do, this is on controlling superintelligence, is an overview we made on that. And these are things, if you want to go into detail, you can look and maybe cast as constraint requirements. The motivation selection thing is, I think, much harder from an RE perspective, because it brings us actually to this point that you would have to deal with goals somehow. And now comes the major story for this particular presentation, and it suits a new theory of the RE problem. I'm not sure whether you know the original formulation by Pamela Safe and Michael Jackson. What I sketch here now is a later version, meanwhile also some 10 years old, by Uret and Melopoulos, and it would say something like you're given domain assumptions, goals, quality currency, and soft goals, references, and what to be found is actually then plans. I mean, plan comes actually from AI, plan to achieve goals. In RE terminology, I would say this is more around scenarios, use cases, something like that. There's a certain correspondence that I also noted 20 years ago. I mean, this formulation is already a little bit polished in this paper now, because I think it's not how it was in this original paper by them, that the quality constraints would be given. It's rather that you start maybe with soft goals, actually something that John Melopoulos introduced a long time ago, and you would actually have to derive quality constraints. But this is not to the point. The point is now that to be found the plans, it would actually be a defeasible consequence that a relation, so for non-monotonic satisfaction, so that for domain assumptions and the plans to be found, you could have the consequence that the goals would be achieved under the given constraints and with certain preferences. Sounds cool, and it includes goals, but it's goals of stakeholders in RE only. And this is not a simple thing, by the way. Then it goes on and on for RE for adaptive systems, when it's more or less switching between configurations, or you could think about rational agents that have goals assigned. This actual work from AI on verification of that, but it's statically designed, given a design time, all the goals given. Yeah, another approach around John Melopoulos, namely how you would kind of develop agents with goals for agent-oriented software systems. But again, it's goals of stakeholders, and they are broken down into goals assigned to agents. So it's actually always the goals of stakeholders. And yeah, the goals of the agent is directly derived, and I hope consistent, because it's sub-goal, whatever. In an AI-based system, an AI-based system may actually create new goals itself at runtime. And it must not necessarily even be a superintelligent for doing that. But on the other hand, if you want to have a superintelligence, I bet it has to be able to create new goals. And this is absolutely not covered yet in terms of theoretical formulations of the requirements problems. So that is actually the point here. I am far, it's a workshop presentation, so I'm really far from any solution yet. But I think I made some interesting observations that I share here. So one is that with the AI safety, that is really not the usual safety thing. It's a safety with regards to superintelligence. The more typical thing would actually be you might have some whatever component in a semi-automatic car, and that component might actually be safe or not. And yeah, in arXiv you might find a recent paper that I did together with an expert in machine learning on how machine learned components of a soft-intensive system might be safety proven, with its probabilities, by the way. So in the respect to superintelligence safety, it's the first RE approach to this issue that I'm presenting here. And I figured out the challenge of extending Gore with dynamic goals of a superintelligence. And the superintelligence will have to be able to formulate goal on its own, and it will do, I'm pretty sure. And then you have a question, how do we deal with this when it's dynamic by the superintelligence itself? When you only, in RE, typically now you would do go with the goals by the stakeholders. So the future work would really be on extending this RE theory to cover goals of a super intelligence. Thank you for your attention.